In this episode, we look at Unit 6, Forces, page 41 from our science workbook. There are forces all around us. A force can be classified as being a push, pull, or twist exerted by one object on another. If a force pushes, pulls, or twists something, there are four main things that could happen. A stationary object might start to move. The speed of a moving object might change. The direction of a moving object might change. The shape or size of an object might change. Animals and machines make forces too. For example, when a grasshopper leaps from a leaf, its legs exert a small force on the leaf. Machines are also used to produce larger forces. The greater the force, the greater the effect it has on an object. If nothing happens when a force acts on an object, it means that the force must be balanced by another force. For example, during a tug of war, the teams may pull with great effort, but there is no effect. The rope stays in the same position. This is because the teams are equally strong and are pulling in opposite directions with the same force. The forces are therefore balanced and no work is being done. When unbalanced forces act on an object, the movement will occur in the direction of the stronger force. Force is measured in units called newtons, named after Sir Isaac Newton, a great scientist who formulated the laws of motion. So Isaac Newton formulated the laws of motion. Some of the basic forces are gravity, friction, and magnetism. We now look at gravity. When you throw an object in the air, it falls to the ground. The force that allows this to happen is Earth's gravity. Gravity is the force that pulls everything down towards the center of the Earth and gives objects their weight. Gravity gives objects their weight. We turn now from page 41 to page 42. The more gravity pulls on things, the greater the weight. The more gravity pulls on things, the greater the weight. The point at which the effect of gravity on an object seems to be concentrated is called the center of gravity. It's called the center of gravity. It is the point where the whole weight of the object seems to act. There is no gravity in outer space. I want to talk about 2 points here before we move on. The more gravity pulls on things, the greater the weight. For example, Jupiter is a larger planet and has a greater gravitational pull. So if we were to go to Jupiter, we would be much heavier than we are on Earth. The moon is smaller and has a smaller gravitational pull on objects on its surface, and that is why we are lighter when we are on the moon. We weigh less because of the gravitational differences. So the mass of the object does not change, but the weight may change depending on the amount of gravity that is exerted on it. We move on now to friction. It is difficult to drag a heavy weight along a rough surface. This is because there is a force called friction. Friction is a force that slows down or stops the movement of one surface against another. When an object rubs against another object, friction results. For example, when you rub your hands together, they become warm. The kinetic energy from the rubbing changes into heat energy and your hands warm up. Therefore, friction produces heat. Friction produces heat. The rougher the surface, the more friction there is. If there were no friction, everything would keep sliding. You would not be able to pick up anything because there would be no grip between your fingers and the object. Friction causes wear and tear. Friction causes wear and tear. That is why even metals wear down. Friction can be reduced by lubricating. Friction can be reduced by lubricating the surface with oil or grease, or by making the surface smoother, We move on now to magnetism. Magnetism is the invisible force of attraction or repulsion between substances, especially iron, steel, or nickel. All magnets have a north pole and a south pole. A magnetic pole pushes or repels poles of the same kind, and pulls or attracts poles of the opposite kind. Like poles repel, and unlike poles attract. Magnetism is strongest at the poles. The region of force around a magnet or magnetic material is called its magnetic field. We move now from page 42 to page 43. When iron filings are placed around a bar magnet, they are always arranged in the same kind of pattern. The lines are more crowded where the field strength is stronger and less crowded where the strength is weaker. These lines are called lines of force. A magnet can be made by stroking or by using electricity. A wire coil that becomes a magnet when electric current moves through it is called an electromagnet. It is called an electromagnet. Electromagnets are found in telephones, earphones, and machines that have electric motors. The Earth acts like a giant magnet. If a bar magnet is supported so that it can turn freely, the magnetism of the Earth makes it turn until it points in a north-south direction. A compass is an instrument that helps people to use the Earth's magnetism to find direction. It has been discovered that one pole of a magnet that swings freely always points north. Floating and sinking. Why does an object seem to get lighter as you lower it into water? Is it because the water pushes against it, supporting some of its weight? This supporting force is called upthrust. It's called upthrust. Upthrust is equal to the weight of fluid an object displaces or pushes away. An object will float if the upthrust is equal to its weight. An object will sink if its weight is greater than the upthrust. When an object sinks, the upward push of the water is not as strong as the force of gravity pulling down. The downward force is the stronger one. Whether an object floats or sinks depends on its density. Density is the amount of mass an object or material has. A cork floats on water because it has a lower density than water. A stone sinks because it has a greater density than water. So if we go back to page 42, we see the bar magnet, and we see that we have a north pole and a south pole. If we go to page 43, we see the lines of forces, and if we were to use iron filings, we would see them have this pattern. They are strongest towards the poles, whether north or south, and they are weakest the farther away you go from the poles. And finally, we have two containers here, and we have one that has something which is floating, which means that the upthrust is greater than the force of gravity on it. And in the first container, we have something that has sunken, which means that the force of gravity is greater on it than the upthrust. We turn now to page 44. On page 44, we have our unit review, and you're going to work through this one, so we'll be able to do it in class together. In our next episode, we move on to Unit 7, Energy Forms. See you then.